First of all, very good afternoon and Assalamu alaikum wa rahmatullahi wa barakatuh. And today topic is about Mirai Botnet. And so this type of botnets is unlike conventional botnets, which is infected conventional networks such as IPv4 or IPv6. It's infected the Internet of Things. So today we'll briefly talk about Mirai botnets, and we see how we can analyze the traffic of botnets using simulated datasets obtained from various sources. Okay, so first start, what is IoT? So if we read about the IoT definitions from different sources, we can find a lot of definitions, but I think the common definitions across these sources is that how to turn any physical object to the smart object. And to do so, the physical object should be equipped in three things. The first thing is sensor. Second is unique identifications, and the last one is connectivity. So when we're talking about sensors, that means that you are sensing the data and send it to the gateway or send it to an intermediate node. And unique identifications here, we are talking about the IP address, such as IPv4 or IPv6. And of course, the connectivity, which is represent various types of the communications protocols, such as ZigBee protocols or 6LoWPAN, and a lot of protocols that which is designed for tiny devices. So this is the number of connecting IoT devices. So by 2025, we will have more 60 million devices connecting to the internet. So from security point of view, this is considered challenging, because one of the most attacks these days is DDoS attacks, and DDoS attacks is based on the number of compromised nodes. So if we find out like half of these devices being compromised by a botnet, and it's instructed to trigger DDoS attacks, so it will be very successful compared to the conventional attack, because it will have a huge number of the connecting devices in the IoT networks. So that's why the IoT connected devices grab the attentions of researchers to find out solutions on how to secure it and protect it from an compromisation from a malicious code such as Botnet. So here is the IoT botnet. So in conventional networks, we have CNC server, and we have different compromised nodes. We call it bot. So here is the CNC server is in charge of responsibility for the communication between bot and bot masters. So bot master basically give instructions for this compromised node to trigger a certain type of attacks, and one of the common attacks here is DDoS attacks. Okay, so when we talk about bot in the conventional networks, so we talk about the inclusion of laptop, your PC, or high-spec machines. But things is changed when we talk about IoT botnet. So back in 2013, a group of researchers from Proofpoint, which is a California-based enterprise security systems, found out a lot of spam locked in the gateway of the networks, and this spam triggered not only from the computer, but it's also triggered from tiny devices such as your CCTV camera or smart TV or your smart refrigerator. So this is unusual traffic. Okay, make the researcher to track the source of this traffic, and from here they called it the bot of things. That's mean the compromised or the malicious code now is targeting the tiny devices instead of the conventional devices. So these devices can be used or can be instructed by malicious, by boot masters to trigger different types of attacks. So here we daily hear about different various attacks triggered from different countries, targeting different servers in other countries. And to be up to date about these attacks, you can have real-time attack trackers from the different websites. So this is example of the websites. Okay, here. Okay, this is website number 1, and this is the second website also. Okay, so here it listed what are what is the locations, the severity of the attacks, and also what is the attachment. And the last one, which will explain it in more details, which is from Netscout. This is also give you more details and access on the current attacks on the network. So if we open this link here, we can have real close. Okay, so here's the real-time attacks and from where it's triggered. And this website gives you filtrations, okay, on the left side. So you can have, like for example, if you are testing from the source, which country you can filter it. Okay, here is a list of countries. Also for the destination, you can identify what is the destinations. And also there are the industry sectors, what are the services that these attacks are trying to target. And also we have here, okay, the event or type of attacks. Is it, for example, here they list UDP or IP fragmentation, IP4, total traffic. So all of this you can tick on any, for example, any event types, and it will be listed here in the filters, and you can see the traffic. But the interesting part about this website is the threat report. So here, if you click on the threat report, it will give you details about the current vulnerability and security issues. Okay, so for example, here we can see so here about the IoT devices. So you have 40 billion IoT devices forecasted to connecting. So this is all about the different types of attacks. But you can also find a lot of things related to IoT devices. And you can also download the reports from previous years. So this report is for first half of each year and the second half. So there are a lot of reporting, security reporting issues. You can find it in this report, and it's very useful for your knowledge and also to be up to date on the current attacks or security threats. Okay, so this is one of the 3 websites that I find it very useful to be visited from time to time to keep your knowledge up to date on the security threats. So let's dive in more details about Mirai botnets. So what is the Mirai botnets? It's a self-propagated malware. When we talk about self-propagating, that means there is no human intervention in the process of propagation. That's when the malicious code of Mirai can duplicate itself very fast, and here is the severity of the botnets. So in conventional, let's say malicious code like worm, so it will be activated when you click on the malicious code or when you plug in your pen drive, so the malicious code will start to propagate. So here, Mirai botnet, no need for any event or action from the human. So this behavior is pretty much like network worm, it's self-propagated. Okay, and the Mirai bot infects poorly protected internet device by using Telnet, and this is the services that expose the tiny devices to the Mirai botnet attack. So here we talk about Telnet, okay, and also self-propagated. So if you can notice here, it's not a new thing, it's not sophisticated. So self-propagations is a method that's been used by different malicious code such as I mentioned, network worms, and it's still not, it's already known that it's also is exposed to various type of attacks if it's not well protected. And this is confirm what I mentioned earlier, that based on the data analysis collected from honeypots attached to IoT, so they find out this kind of malicious node is not really sophisticated. It feels like as the user might not notice, their devices are being exploited. So, and this malware, the Mirai botnet, is a family behind 39% of attacks of Mirai. So, as we know, later I will explain the timeline of Mirai. So there are various types of Mirai malicious codes that adopt the codes of Mirai and use it for malicious purpose. So here the attacks is aimed to check the devices and control it, and using very old techniques called also brute force attacks. So if you can also again here brute force attacks, self-propagations, telnet service is all not really sophisticated. So but here the victims is the users, okay, who are not aware about the severity of left their devices unpatched. So, but why the Mirai botnets gain popularity? So if you look, and this is for the three, or let's say the one main reasons. The first thing is Mirai botnet hit very well reputed institutions and blogs. The number one is CRISP on security, which is a very famous blog on that security. So this is Mr. Grips is a journalist who are investigating cyber criminals. So this blog is being also under the Mirai botnet in 2016. And this is the beginning of the Mirai botnets. This started in 2016 and it's identified in 2017. So it's also targeting a D1S provider for very well-known service provider, for very well-known companies such as Amazon, GitHub, Netflix, PayPal. And that's why this Mirai botnet is become very well-known. And another also victim was Lone Star Telecom operator. So these all three incidents happened in 2016, and it was unable to identify until 2017. On 1st of January, the author of Mirai botnet is identified. So here is the global distributions of the Mirai botnet. Okay, and this is distributions is based on honeypots networks, which analyze the traffics of botnets, and we find out the Brazil, we can see, is the number one all the way to Argentina, last on the list. So, what is the life cycle of Mirai botnets? So first is scanning, and we're talking about scanning it's the first stage for any malicious code. It's not only about Mirai. You know, if in botnets or in network worm, the first step for attacker to gain access to any networks is to do network discovery. And network discovery is scanning. So scanning here is to find out the vulnerability in vulnerability in the victim devices. And in case of Mirai botnets, we are targeting TCP port 23 or 2323, which is a telnet services. So if this service is unidentified, then we have to do brute force dictionary attacks. Means that we want to guess the username and password. And here, even though this is very simple, but yet it's very efficient because most of the users do not update the default factory password and username and password. Anyone like my CCTV camera or your router at your home, you know, you will not update the username. Most probably you will not update your username and password. And we have a lot of tiny devices connected to the internet with the factory default username and password. So we can guess this username and password using this type of attacks. So once this service is identified, the infection will take place. That means the malicious code will be loaded in the the victim devices, and the new devices will act in the same way that it's infected by. It will start doing also scanning and find out many or other victim devices. So here this chart summarizes the life cycle of Mirai botnets. So we have here different layers. We have attacker, infrastructures, device, and DDoS target. So first we have the bot, which is scan for the devices with telnet service, and it will report to the report server. Report server will dispatch the loader, and the loader will load the malicious code to the victim. So once it's loaded to the victims, the attackers will send commands to these victims to trigger out different types of attacks, and one of the major attacks is DDoS attacks. At least in Mirai botnets, there are different types of attacks which is fall under DDoS attacks, and we'll talk about this later on the coming slides. So the Mirai botnet, So Mirai attack vectors, we have two types of attack. First is brute force attack, and second is DDoS attacks. So brute force attacks is during the scanning, and as I mentioned earlier, is to guess the username and password. So if the username and password match with the predefined list of username and password, then the attacker will gain access to the victim device. And once it's gained access to the victim device, it will trigger DDoS attacks. Okay, so there are different types of DDoS attacks, so we'll mention about it later. So here is the first attacks, is brute force attacks, and this brute force attacks, as I mentioned, is attempt to crack username and password. And here, this is a snapshot from the code, from the Mirai source code. As you can see here, in the right side, this is the username, the default username and password that is hard-coded inside the code. And by the way, this code is already available. We'll have a look on this code. So you can see here all hard-coded. And this code is already in the internet. So that means if you have a new list of username and password, the pair of username and password, you can update this code and trigger your attacks. That's why there are a lot of variants of Mirai botnets, which adapt the source code and add new techniques or update the dictionary to have more recent username and passwords. So the second type of attacks is DDoS attack. So DDoS attacks is not recent attacks. It's been for quite a long time, but the efficiency of DDoS attacks in the presence of Internet of Things become more efficient, and this is due to the huge number of the devices connecting to the Internet. So earlier in the figure I said that more than 60 billion will be connecting to Internet by 2025, and according to Cisco, by this year there will be 20 billion devices connecting to the Internet. And with the poor security of the tiny devices, which enable the attackers to easily compromise these nodes and recruit these nodes to trigger different types of attacks. So the DDoS attack will be more efficient because it depends on the number of the compromised nodes. So here we have different sync spots, and it's targeting to the one victim. So this is also the percentage of about the DDoS attacks, okay, based on the analysis of the botnet, of Mirai botnets. So we can see that here 80% of TCP state, 80% of application attacks, and this one is it's based on the analyzing of also the source code. If we move here to the vector attacks of DDoS attacks, we have different types of attacks, which consists of 10 attacks, such as TCP flooding attack, HTTP flooding, and we have all these attacks. Okay, so this is also not new attacks. This is also like been quite long in the internet. It's not also sophisticated. So as we can see here, Mirai using the old methods, and it's using also a very simple infection mechanism like brute force attacks, and the DDoS attacks also that it's used is very easy to identify. And also this code, attacks vectors is extracted from the code, the source code of Mirai botnets. Okay. So the Mirai botnets, you can find it in here, in this GitHub. Okay, if you type in this link, you can download it and you can have a look. Okay, so two things I mentioned earlier. First is the brute force attack, and the second one is DDoS attacks. And I already downloaded the source code of the Mirai botnets. You can download it and you can go to the Mirai bot folder, and you will see two files. The first one is attack.c and the scanner. Attack.c, which is a C written in C programming language. Here you can see this is 10 types of attacks that I mentioned earlier in this slide. So this is, if we click here, okay, so this 10 attacks extracted from this file, okay, and the brute force attack here we can find in scanner.c, and this is the default, this is the default username and password for different type of the timing devices. So it might be CCTV cameras, it might be smart TV. So you can download this source code and you can update this one, or you can adapt the new techniques for it. Okay, that's why we have a lot of Mirai variants bot, because the source code is already there. Okay, so we can see here is admin 1, 2, 3, 4, 5. We have admin 1, 2. It's all the default, right? And this is can work. So you may wonder if it can work or not. Yes, it can work because most of the users, as I mentioned earlier, do not update the default username and password. So usually admin is the common username and password. So if the Mirai botnets identify your device as a victim and your username and password is among of this dictionary, that means your device will be infected. Okay, so you can download this source code and you can also do reverse engineering and see how the attackers write their malicious codes, or you can use it for research purposes. So okay, so this one, all the attacks, and so here is the Mirai adaptations and variants because of availability of the source code. So what we can do to prevent such of these attacks, we can update it from IP base to the domain base, for example, deletion, fixation, binary, and more username and password pairs. This is how the variants update the Mirai botnets. Okay, so for example, they add new username and password pairs, and the closing of the infection port TCP 23, and the in point number 1, they shifted it from IP base to domain base. And you have your own adaptations also. Okay, maybe you come up with new techniques, you can add it on the Mirai source code, and it will work because it's open source. So this is some of the best practice how to defend against Mirai botnet DDoS attacks. So basic security practice like not using default username and password, automatic update and out-of-bound notifications, and mechanism for end-of-life devices. Okay, so if you stick on number 1, okay, which is the base for brute force attack will be saved at early stage. Okay, so update your username and password, because the default username and password is the key or the base for the Mirai botnets, which is use brute force attack to guess the pair of username and password. Okay, there are a lot of data sets available that you can understand, analyze the Mirai botnets. So here I share with you 3 data sets, okay? Because if you wanna experiment Mirai botnets, you have to build your isolated testbed, okay? And from the testbed you can collect the traffics and use this traffics as the input for your, for example, security mechanisms or for analysis purposes. For that we have already have 3 available datasets, and these 3 available datasets provide different type of tiny devices. You can read about it more details, but we will use the 3rd one to show you the Mirai botnets in form of bcap files. Okay, so if you wanna follow up with me, or I will do a very simple demo for you, but the datasets is available here. If you want to download it, you can go to this website and you can key in 478155. There are 2 links, one Dropbox and one also Google Drive. You can download all these datasets and you can follow me on how I will show you to analyze the traffic of Mirai botnets. Okay, so here we have a link I already so if you type Minty, okay, so here you key in the username 478155. So 478155, right? So you will have 2 links. You can use either one. So I already downloaded the datasets from this link, and you can okay. So there are the whole data here, and there are trace2 folder inside. So there are different speakup files represents different type of attacks. So we're going to see, like for example, Mirai brute force attacks. We'll see whether we are able to capture telnet traffic, filter it using the Wireshark. So I already have Wireshark installed here in my machine. Okay, and I already have, for example, this file, Mirai brute force attack. So I will open it using the Wireshark. Okay, so you can do you can do analysis for this traffics with help of the Excel sheet here. So in Excel sheet here we have the file name and what are the file name and what are the Wireshark filters you will apply it. So we have a lot of files. For example, each file represents one type of attacks. Like you see here, scanning, sync flooding attacks, and we have voice discovery, which is scanning. So here we are focusing on brute force attack. Okay, here first we want to filter it based on the protocol. So if I have, let's say, I have a network traffic, I want to filter out the TCP telnet. So for example, if I have a group of 10 devices connecting to the internet, and I want to find out if there is an attempt to guess the username and password of the telnet or not. So I will capture the traffic and simply type telnet. Okay, so I will get all the telnets traffic here. And as we can see here, we click on telnet here, we find here is data also. Okay, again, start for data. We have a lot of things here. All telnet. For example, username, we capture it, right? So this telnet is over is over TCP. So that's mean it will send the data separately. So that's why we have to do group by TCP stream. And see here, simply we find that there is a guessing here. Sometimes root, this is the password, root, and this is the password also. That means there's abnormality here. Okay, and because we already have a labeled data sets, right? And mentioning that this traffic is doing brute force attacks, and we are able to find out the username and password, the guessing. And the reason for that, we are able also to extract the username and password because there is no encrypted channel between.